The Intel processor story begins in 1971. Intel introduced the 4004. This was the world's first commercial microprocessor. It was designed for calculators. Before this, computing logic was spread across many chips. The 4004 combined everything into one. It processed 4 bits of data at a time. It could only handle very small numbers. Its clock speed was about 740 kilohertz. Think of it like one cashier in a tiny shop. Slow, but revolutionary. It proved something important. A computer could exist on a single chip. In 1974, Intel released the 8008. This was an 8-bit processor. It handled larger numbers. It enabled programmable machines. Its clock speed reached 2 megahertz. Early experimental computers became possible, but systems were still complex to build. In 1978, Intel introduced the 8086. This is where modern personal computing begins. It was a 16-bit processor. It could address up to 1 megabyte of memory. That was a major leap. Think of memory like a warehouse. The 8086 reached more shelves. Clock speeds ranged from 5 to 10 megahertz. IBM chose a related chip, the 8088, for its first PC. This decision shaped the future of computing. Backward compatibility became a rule. In the early 1980s, Intel released the 286, also called the 80286. It introduced protected mode. Programs could be isolated. Think of walls between apartments. One crash does not destroy everything. Clock speeds reached 25 megahertz. Software support was limited. Most programs stayed simple. In 1985, Intel introduced the 386. This was Intel's first true 32-bit processor. It could address 4 gigabytes of memory. Multitasking became practical. Modern operating systems became possible. Clock speeds reached 40 megahertz. Heat and cost increased. But the foundation was set. In 1989, Intel launched the 486. Cache memory moved onto the chip. Math processing was integrated. Think of keeping tools on your desk. Clock speeds ranged from 25 to 100 megahertz. Systems felt noticeably faster. In 1993, Intel introduced the Pentium. Intel moved from numbers to names. This improved branding. Pentium could execute 2 instructions at once. Think of 2 cashiers instead of 1. Clock speeds started at 60 megahertz. Early bugs were later fixed. In 1997, Pentium 2 arrived. Cache was improved. In 1999, Pentium 3 followed. Multimedia performance improved. This defined late 1990s computing. In 2000, Intel launched Pentium 4. This design focused on very high clock speeds. Think of a long assembly line. Fast but inefficient. Speeds reached nearly 4 gigahertz. Heat became a major problem. This approach did not scale well. Pentium 4 is often seen as a misstep. Alongside Pentium, Intel introduced Celeron. Celeron was a budget processor. Lower cost, lower performance. Office systems benefited. Power users did not. In 2006, Intel changed direction. Intel introduced the Core architecture. Efficiency became the priority. More work was done per cycle. Think of smarter workers, not faster belts. Core 2. Duo introduced true dual-core processing. Multitasking improved. Intel recovered. In 2008, Intel launched the Core i series. Core i3, Core i5, Core i7. These were market tiers, not generations. Think of car trim levels. Later, Core i9 was added. Here is where confusion begins. Generation matters more than the name. An older Core i7 can be slower than a newer Core i3. Manufacturing improved over time. 32 nanometer, 22 nanometer, 14 nanometer. Power efficiency improved. Integrated graphics became usable. In 2021, Intel introduced hybrid architecture. Large performance cores, small efficiency cores. Heavy tasks go to large cores. Background tasks go to small cores. Think of trucks and scooters sharing roads. Efficiency improved. In 2023, Intel introduced Core Ultra. This replaced the traditional Core I naming. Core Ultra introduced dedicated AI hardware. The neural processing unit. The CPU handles general tasks. The GPU handles graphics. The NPU handles AI tasks. This includes image processing and noise reduction. Core Ultra also uses a chiplet design, different parts built separately, then packaged together. Efficiency improved again. This marks Intel's move into the AI PC era. Now, common misconceptions. Clock speed alone does not equal performance. Core count matters. Architecture matters. Nanometer numbers are branding terms, not physical sizes. Buying advice is simple. Office work needs fewer cores. Gaming prefers strong single-core speed. Editing benefits from more cores. Do not overpay for unused features.